Hi, this video is an answer to a common question that people have about Newton's third law, which is basically if forces are always equal and opposite when there's an interaction, why don't they always just cancel each other out? So we have an example of pushing on a door. So you push on the door pushes back on you. Why don't those two forces just cancel out and then nothing happens? The door doesn't move, you don't move. Why doesn't that happen when you try to open the door? The short answer is that the two forces are acting on two different objects. So force number one, you push on the door. And so we have the first force, the thing that's getting pushed is the door. Force number two, the door pushes on you. And so this is a different object being pushed. So both the door and you are getting a push. And so potentially both of you could end up accelerating. The door moves forward and you move backwards. However, if you have shoes that have good traction, then maybe you can resist being pushed backwards by your push against the door, and so you don't end up accelerating backwards as you open a door. I've drawn free body diagrams over here for this situation, and the point is that there are two free body diagrams because there are two objects. You push on the door, and so the door has a net force to the right in this picture. The door pushes back on you, and so you're pushed to the left by the door, but assuming that your feet have friction and static friction that keeps you from sliding and slipping, then that static friction can counterbalance the force of the door pushing back on you, and you don't end up accelerating backwards when you try to open the door. But imagine if you removed the floor and you were just in outer space and you tried to push open a door, right? You might be able to get the door to open, but the reaction force would push you backwards. And so this friction may not be there, and you might actually end up moving backwards as a result. So every force still has an equal and opposite force, but those two forces are acting on two different objects. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.